In this lesson we're going to talk about wavelength and amplitude. Supposing I'm generating a water wave here, I'm moving an object up and down, and as I do so the wave moves in this direction. We say that the wave is propagating. The old-fashioned word. Nowadays we just use the word travelling, so we say the wave is travelling, okay, in this direction. And so what we've done here, as it's travelling, as it's moving in this direction, we've taken a snapshot of the wave in space. Okay, so this is the wave frozen at a moment in time. Right, and we're going to point out some important features about the wave. First of all, the distance from one peak to an adjacent peak is called the wavelength, and it's also exactly the same as the distance from one trough to an adjacent trough, and that is given the Greek symbol lambda, pronounced like that, lambda. So let's measure the wavelength by putting a grid on top of the wave. Let's just assume, for the sake of argument, that each of these squares represents 5 centimeters. So that means the wavelength of the wave is 4 times 5, that's 20 centimeters. So the height of the wave above the axis here, above this axis of propagation, is known as the amplitude. Let's just write that. Now a wave is something which transfers energy from one place to another, and the amplitude is really a measure of how much energy the wave carries. So if we increase the amplitude of the wave, that's to say we increase the size of the vibration up and down here, then we increase the amount of energy that it carries. So this wave has an amplitude of 510 centimeters. Then if I increase the amplitude of this new wave has now been increased to 15 centimeters. Okay, so this new wave will carry more energy than the previous wave because its amplitude is greater.